Okay, this is site 4 on the Antiburn, and what I'm going to be explaining to you shortly is a range of factors that could be affecting the different characteristics of our river. Before we get to that though, let's just do a quick review about what we are expecting to have happened with the river by this stage. Now, according to Bradshaw, we would be expecting the discharge to have increased from the previous site, site 3. We would have expected the sediment in the river, the pebbles, to have continued to get smaller due to an increase in the rate of attrition on those rocks. And likewise, we'd expected the material in the river to have got more rounded. And finally, the efficiency of the channel we would have expected to have increased. So the hydraulic radius should be higher than the previous site as the river started to get deeper and wider and has more water, and therefore can move water through its channel more efficiently. So let's just examine what's happening at this location when we look at our data. What are the analytical points we're likely to make? So let's start with discharge. Will the discharge have increased? Well, at this stage, we can clearly see that the river's quite deep. That suggests the discharge has jumped quite significantly between site 3 and site 4. What are the reasons for this likely increase? Now, assuming your data shows that this increase has happened, the first factor that could be explaining this could be the fact that we are now back onto a much harder rock. We can see that the river's no longer cutting such an incised V-shaped river channel, and that's because the rock's much harder now. We're back to a basaltic rock, which is an igneous rock, which is much harder. Therefore, no water is being lost through percolation. That's where water infiltrates into the permeable rock, and therefore the river's capturing all and not losing anything. So that's one significant factor why the discharge is likely to have increased. Other factor is that between here and site 3 we do have a tributary stream which will have caused more water to be discharged into the river between site 3 and 4, thus increasing the discharge at this particular location. So that's a second factor likely to have influencing the discharge of the river. Now, if we have a look at some of the other factors, will the bedload size and shape have done what we are expecting? Is rock size getting smaller? Well, actually, when we look at our data, you might very well find that it's actually getting larger, which is not what we expect. And I'm looking in the river channel to explain why that's the case. Now, rock size, we can see lots of man-made material like those concrete conglomerate rocks down there. We can also see in the river channel we've got quite a lot of bricks. So there's quite a lot of material that's been dumped into our river channel. There's more bricks. That is meaning that, assuming we've measured some of these, which we might have done as we crossed the river channel, they may have been the rock we measured. We're actually getting an increase in rock size, and it's not due to natural processes. This is man-made. We have quite a lot of development around the river here. We have a park, and in the background we have a relatively new housing estate. And what's clear is that a lot of the building materials that we used in the construction of the housing estate, the park, and the bridge itself, which I happen to be standing on, have ended up in the river, and therefore they cause the average size to increase. It's that same reason why we're going to see a lot more angular material in the river. A man-made material like a brick is obviously a very angular object, and because a lot of the material in the river has been added by humans dumping it in the river, it's likely that we're going to see more angular and subangular rocks when we might be at this stage expecting the river to start having rounded its material. We may not be seeing that yet because of this human factors leading to more material being added into our river. So that's a factor that could be causing both our rock shape and our rock size to not do what we're expecting. So our final factor that's being measured in our river is the efficiency of the channel. Is the river becoming more efficient? Well, there's a couple of factors acting against efficiency, which is all of this material that's been dumped in the river. So we would expect that to have an effect on slowing the water down, because we've got all these big, large, angular rocks, reducing the efficiency. However, countering that factor is the fact that, as we can see upstream, if I just look there, we have a big increase in discharge. So with more water, even though our channel's got a lot of large man-made objects in it, because there is a lot more water, in our river. It's scouring a deeper, wider channel at this location, which means that water can move through the channel more effectively. So that's a positive force. However, a negative force, we can see a large tree and vegetation growing and actually going into the river channel itself. We can see the root systems in the river down there. Now, they're going to be acting as a brake on the river and slowing it down. So overall, I would expect the efficiency to probably be a little bit higher here than Site 3, but I wouldn't have expected a significant jump because of the factors like the vegetation, the large bricks in our river channel, and the final factor, which is the bridge itself, which is interfering, the supports of this bridge are interfering with the flow of water, which are actually potentially slowing it down slightly. Okay, so that's Site 4 reviewed, looking at the various factors that you will be looking to use when you analyze your own results.